Okay, the topic of this lesson is finding coterminal angles. Okay, and again, starting out with bell work number 1 here, you're going to evaluate the 6 trigonometric functions for the triangle using angle B. Again, make sure you note that you are using angle B. You are not using angle A here. Okay, so the first thing I need to do here is use the Pythagorean theorem to find side A. So I'm going to go ahead and label my triangle as angle A, angle B, angle C. This would then be my side B because it is opposite of my angle. Side C is my opposite of angle C. So if I find angle or side A, I have A squared plus B squared equals C squared. I use the Pythagorean theorem because I have a right triangle. I plug in A squared because I don't know that one. But I have 10 squared equals 19 squared, which gives me A squared plus 100 equals 361. I would then subtract the 100 from both sides. That's going to give me A squared is equal to 261. I'm then going to take the square root of both sides. And again, here I'm going to go through and try to find any perfect square factors of 261, because 261 itself is not a perfect square. Okay, so if I take the square root of 261, I do not get a nice integer value. However, again, for the purpose of saving some time on the video, I get the value of A to be now the square root of 9 times 29. Plug that in your calculator. That is a perfect square times a non-perfect square, and then does not have any factors that are still perfect squares. Okay, but the square root of 9 is 3, so A is equal to 3 square root of 29. Okay, and again, my suggestion for these was to write the phrase so, toa at the top of your page, because again, that helps you remember what the ratios are that I'm setting up. Okay, so sine, and again, using angle B. If we're using angle B, this is my opposite side. This is now my adjacent. And this is my hypotenuse. Okay, hypotenuse. So sine of angle B is equal to the opposite over the hypotenuse, which is 10 over 19. Okay. I can't reduce that anymore, so that is my answer. Cosine of B is my adjacent over the hypotenuse, which the adjacent is the 3 square root 29 over 19. Okay. And then if I go with tangent, tangent of B is my opposite over my adjacent, which ends up being my opposite is 10 over 3 square root of 29. Okay, so here we have a couple, again, things to look at. Can I reduce 10 over 3? Correct answer to that would be no. Can I have a square root in the denominator? Again, that answer is no. So in order to get rid of that square root, I need to rationalize. I need to multiply the top and the bottom by that square root. and that would give me 10 square root of 29 over, this is 3 times 29, because remember again, the square roots will then cancel out. So 3 times 29 is 87. Okay, so there's my values for sine, cosine, and tangent. Now again, the last of the 6 are the reciprocal functions. So for sine, the reciprocal, that is cosecant. So CSC of angle B. I'm going to take this and I'm just going to flip it. Okay, again, that's my reciprocal. So I have 19 over 10. Okay, I can't reduce that, so that's done. For cosine, the reciprocal is secant. I'm going to backtrack that a little bit here, give myself some room. If I flip that, I have 19 over 3 square root of 29. And again, it puts me in a predicament like I do here with tangent, and I have to get rid of that square root. 3 and 19 cannot reduce, similar to what 10 and 3 were. And I can't have that square root, so I need to multiply the top and the bottom by the square root of 29, which is going to give me 19 square root of 29 over, again, that 87 from here, because 3 times 29. And then cotangent, the reciprocal of tangent. Again, I'm going to backtrack. If I take this and I flip it, I'm going to have a situation like this where I have to simplify, and I don't want to do that. Here I multiplied to simplify, but here, if I take this and flip it, I don't have to do any simplifying. So that would be my answer. So the answer is 3 square root of 29 over the 10. Okay. Moving on to number 2, 2A here. Draw the angles in standard position. So again, what I'm going to do here is I'm going to take, because this is a large enough negative, I'm just going to add 360. And again, I'm going to continue that until I get someplace between 0 and 359 and negative now, because this is a negative. Okay, so if I'm going to add 360, I get negative 515 degrees. I'm going to add 360 again, and that's going to give me negative 155 degrees. Okay, so my initial side, again, is on the positive x-axis. Again, this line is always here. Negative 155, I have negative 90 if I go down first. This is negative 180. Okay, so I'm 25 degrees off of here. So I'm not too far. Okay, we'll call it there. Again, now looking at how many times I added or subtracted 360, I added 360 twice. So I have 2 full rotations, and then I have that extra 155 degrees negative. So I start here. Negative means go down first. I'm going to go up and around. 1, 2, and then finish it out. Okay, the 1,440 degrees now, I'm going to take that, I'm going to add 360 degrees. Sorry, subtract 360 degrees. When I do that, I have 1,080 degrees. I'm going to continue to subtract 360. This gives me 720 degrees. I'm going to again subtract 360. That gives me 360 degrees. And then I do it one more time because I'm not between 0 and 359. And that gives me 0. So you'll notice here that I have 1, 2, 3, 4 full rotations because I subtracted 360 4 times. 1, 2, 3, 4. So what's going to happen here is I'm going to have this initial side, but the terminal side falls on that axis as well. So in order for me to understand that you understand that I have both the terminal side and the initial side on this axis, I need to see two arrows. So I have an arrow there and another arrow indicating again that I have both of my lines on that axis. Okay. And then I'm going to graph. So I start here. Positive, I go up first, so I go up and around, and I have 4 full rotations. So I go up and around 1, 2, 3, and I end right on that line. That's 4. Continuing with the notes, we have 4 pages of notes to go through. Coterminal angles, by definition, are just angles that are, when graphed, the exact same standard position, just a different value. Okay. So if we look back at what we did on the bell work, we actually did some of that that we're going to do. Okay. So second page here, finding a coterminal angle. This goes through the process. So understand, with degrees, I want you to leave it in degrees. And in radians, when graphing in standard position, I would like you to change the radians to degrees. However, here, I would prefer that you stay in degrees. Sorry, in radians. Okay, so the process is this. We're going to either add or subtract 1 full rotation depending on the number that I give you. Okay, I am looking for 1 positive and 1 negative coterminal angle. Okay, so things to pay attention to. And again, this is one of those things where I wish that I didn't have to say this. However, I have to say it every single semester that I teach this section. When I am looking for a positive coterminal angle, you know it is a positive coterminal angle when you have a positive number. You have a negative coterminal angle when you have a negative number. Okay, it cannot be the same number that I gave you to begin with. It has to be a different number. Okay, but I can either add or subtract a full rotation. Again, depending on the value that I give you, you may have to do one of each. You may have to add and then go back and subtract instead. Or I give you a number that's large enough, either positive or negative, that maybe all you have to do is add, or maybe all you have to do is subtract. Okay? So again, pay attention to what I give you. So examples. Okay? Again, 2 pages here. I'm going to give you 2 that are in radians, and then 2 that are in degrees. Okay, and we're just going to work them out. All right. So again, I'm just going to start just like we did with the standard position, and I'm just going to start adding, because this is a large enough negative number that I'm just going to add 360 degrees. So I'm going to add 360. That gives me negative 1,715 degrees. I'm going to add 360 again. It's going to give me negative 1,355 degrees. I'm going to add 360 again. That gives me negative 995 degrees. I'm going to add 360 again. That gives me negative 635 degrees. I'm going to add 360 again. That gives me negative 275 degrees. Okay, the difference between what we did before with graphing in standard position and this one is that I'm still looking for a positive value as well. So I'm going to add one more additional 360 here. So I'm going to add 360. And I get 85 degrees. Okay, so again, a coterminal angle is an angle that's going to give me the exact same standard position if I graphed it, but it's not the same value. So it just has one less spiral to it. Okay, so if I add 360, that gives me a coterminal. So this value here is a negative coterminal angle. Okay. When I added 360 again, this gives me another negative coterminal angle. When I add 360 again, I got another negative. This gave me another negative coterminal angle. Okay, you only need to identify one of these. I added 360 again, I got another negative coterminal angle. When I add 360 again, I got another negative coterminal angle. Okay. And then when I added 360 again, I finally ended up with a positive coterminal angle. Okay, so on the homework assignments, you'll see two columns, 3 columns actually. The first column will be the angle that I'm giving. The second column at the very top, it says positive coterminal angle. And then the third column says negative coterminal angle. You need to identify a positive in the positive coterminal column and a negative in a negative coterminal column. Okay, so on this problem, you would be able to put one of these on the negative coterminal angle. Okay, we could have also subtracted 360 and got a larger negative number. But because this is large enough negative, I can just add 360 to continue getting negative values. Okay. Moving on to the next one. Again, it's large enough positive now that I'm going to be able to just subtract 360. So if I subtract 360, I get 1,264 degrees. I can subtract 360 again. It's going to give me 904 degrees. I can continue subtracting 360. It's going to give me 544 degrees. And we're going to continue subtracting 360. That's going to give me 184 degrees. And because again we need to get to a negative value, I'm going to subtract 360 one more time. It gives me negative 176 degrees. Okay, so again, looking at what we have, I can identify several positives and then one negative. So again, here, this, because I added 360 or subtracted 360, this is now a positive coterminal. Okay. And again, that's because it is a positive value. This is another positive because this came out to a positive value. This is another positive coterminal because it came out to a positive value and I subtracted 360 again. This is another one. And finally we get a negative coterminal angle. This is a negative coterminal because again it's a negative sign, so negative coterminal angle. Okay, and on the flip side again here, instead of subtracting 360 all the time, we could have added 360. And if I would have added 360 to the 1,624, I would have ended up with 1,984. That would also be a positive coterminal angle that would be acceptable. Okay, moving on to radians. Again, in radians, I want them left in radians. And this is just going to require you to go back and touch up on your fraction, addition, and subtraction. Okay, so it shouldn't be that complicated. we're going to add or subtract 2 to these. Again, it's 2 pi for one full rotation. So if I have a negative 15 over 2, that's a large enough negative that I can just add 2 pi. So I'm going to put plus, and I'm going to put 2 pi, and I'm going to put that over 1. Okay? In order to add fractions, we have to have what? We have to have a common denominator. And in order to have a common denominator, we have to have the same number in the bottom. In order to do that here, because this fraction has a 2 in the denominator, I'm going to multiply here and here times whatever this number is. So times 2 and times 2. Which now gives me that negative 15 pi over 2. And I'm going to add 2 times 2, which is 4 pi over 2. Okay, and make note that the denominators stay the same. The 2 stays the same. So now I just look at that negative 15 and I add 4. Okay, so negative 15 plus 4 is negative 11 pi over 2. And then I'm going to take this and I'm going to bring it back down. Okay, and I'm going to take that and do the same thing again. So negative 11 pi over 2. I'm going to add, and again I can stay with this 4 pi over 2. So now negative 11 plus 4 is negative 7 pi over 2. And I'm going to continue. Okay, and again, I'm going to continue until I get a positive because I need one of each. So I have negative 7 pi over 2 plus, again, that 4 pi over 2, which gives me negative 3 pi over 2. And again, one more time now. I have negative 3 pi over 2 plus the 4 pi over 2, which is going to give me 1 pi over 2. Okay, so again, looking at these going down, I have several negatives still. So this is a negative. Coterminal. This is a negative coterminal. This is a negative coterminal. And this one finally turned out to be a positive coterminal. Okay. On number 4, the last one here, again, we're going to look at the fact that it's a positive, and it's a large enough positive that I can subtract 2 pi. And when I subtract 2 pi, again, I'm going to do similar to what I did over there. I'm going to subtract and I'll put 2 pi over 1. I need a common denominator here because the denominator here is 4. Even though it looks like a 4 over a 4, it's just 4. And I'm going to multiply both here and here by 4, which gives me that 19 pi over 4. And I'm subtracting now. 2 times 4 is 8 pi over 4. Okay, and then I'm just going to continue to repeat that process now. So 19 minus 8 is 11 pi over 4. I'm going to then take this and work it down. So 11 pi over 4 minus, again, 8 pi over 4. 11 minus 8 is 3 pi over 4. Continue one more time. We get 3 pi over 4 minus the 8 pi over 4, which gives me now negative 5 pi over 4. Okay, and again, now that I have positives and negative output values, I have one of each at least. So again, if I'm going through here, this is a positive coterminal angle. I added one rotation there. I'm sorry, I subtracted one rotation. Here I subtracted another one. This gave me another positive. And then when we subtract it again for the third rotation off, we end up with a negative coterminal angle. Okay. As always, if there are any questions, comments, or concerns, or something that I can just clarify, okay, please, by all means, reach out to me and ask.